Okay, today we're going to talk about solving equations. So this should be review. However, I know it's been a little while since you've done a lot of the equation solving. So hopefully you've got your notes out and you are ready to write some things down. There are 3 things to remember when you are solving equations. And the first thing is always remember that you are trying to get the variable by itself. And this is true whether you are solving simple equations that we're going to start out with, or if you eventually are in a calculus class or a very high-level math class and you're solving an equation, you need to try and get the variable by itself. The second thing you need to remember is you are always going to use the inverse operation. So if it's an addition equation, you're going to use subtraction. If it's a multiplication equation, you're going to use division. If it's a square root equation, the inverse of square rooting is squaring. So you always use the inverse operation when you are solving equations. And the third thing to remember is whatever you do to one side, you must do to the other. We're dealing with equations. We have to make sure we keep it equal. So whatever you do to one side, you must do to the other. You could ask, remember, you can always ask the substitute to pause this if you need it paused. So let's do some examples. The first example, we have 2p plus 15 equals 29. So remember those 3 steps. We need to get the variable by itself. So I need to get the p by itself. Also keep in mind we need to do the order of operations backwards. So we have 2 different things here. We have multiplication and we have addition. So normally you would multiply first, but we're going backwards. We are undoing the process, so we're going to have to subtract 15 from each side first. Okay, so we end up with 2p equals 14. Then we need to undo multiplying by 2, so we divide each side by 2. These 2 cancel, the 2's cancel because the 2 goes into 2 one time. So we're left with p equals 7. Now I'm not going to require that you check your answers, but remember you can always verify. Plug the 7 back up here for p. 2 times 7 is 14. 14 plus 15 is 29. So when you solve an equation, you can always check it and know that whether or not your answer is correct. Okay, example 2. Here, the thing to keep in mind, before you start solving, before you start doing inverse operations, you always want to combine like terms. So take a look at your equation you're solving and look at each side of the equal sign. Here I have a whole bunch of terms with a's, so I'm going to combine those. 7a minus 3a is 4a, plus 2a is 6a, minus, remember there's like an invisible 1 here, so we have 5a equals 16. So that's the first step you want to do. Now we want to undo multiplication, so we divide each side by 5. And my answer, a equals 16/5. It is fine to leave your answer as an improper fraction. It is simplified because there's nothing that goes into 16 that also divides into 5. So you can leave your answer like that. If you want to change it to a decimal, you can, but you don't need to. All right, the next example is dealing with fractions. And chances are most of you don't like doing fractions very much. As a matter of fact, when I look at that computation worksheet I made you do on the first day, I'll see how good of a job you do with fractions without a calculator. So one of the things you can do is what I call fraction busters, and that is get rid of the fraction by multiplying everything by the least common denominator. So think about if you were adding things with fractions, what you would do, you have to find a common denominator. And in this case, we could use 18 because 3 goes into 18 evenly and 9 goes into 18 evenly. So what I'm going to do is I'm going to multiply everything by 18. And if you want, you can put an 18 over 1. So I'm multiplying 18 by the 1/9, 18 times the 2/3 b, and 18 times the 1 over 18. So when I do that here, 9 goes into 9 once, 9 goes into 18 twice. So I cancel and leave a 2 times the 1 that was already there, and I get 2. Now I don't actually cross it out because I don't want to cross the 18 out because I also have to multiply it by this next term. 3 goes into 18 6 times. Times the 2 that was already there gives me 12. So I have 12b. And for the last part, 18 goes into 18 one time, times the 1 that was already there is just 1. So now in one step, I have just eliminated the fractions, and now the problem is much easier to do. So going on next, I would subtract 2 from both sides, and we get negative 12b equals negative 1. Then I'm going to divide each side by negative 12 to get the b by itself, and we get b equals 1/12. And that's the answer. Okay, on the next problem, this example, I'm going to actually show 2 different ways that you can do this problem, and you can kind of see when you would prefer which method. So we have 27 equals negative 9 times the quantity x plus 5. And the first method I'm going to use is, so I'm going to copy this problem down. The first method I'm going to use is to start by dividing each side by negative 9. So I'm going to divide this side by negative 9 and this side. Over here they cancel. I'm left with negative 3 equals y plus 5. And now I can subtract 5 on each side, and I get y equals negative 8 is my answer. So that's one method. The second method is I could also start off by distributing the negative 9 and have negative 9y minus 45. Then remember, I'm trying to get the y by itself, so I need to add 45 to each side. So I have negative 9y equals 18. No, that's not right. Oh, subtracting. Don't want to do that. So we're going to have 72. Divide each side by negative 9. And we get y equals negative 8. So either way, you get the same answer. However, notice how in the first method, it was a lot easier because I made my numbers smaller right away by dividing each side by negative 9. That's a good method because the negative 9 divided into 27 evenly. That's when I would go with the dividing first instead of distributing. Had this been a number that did not divide evenly into 27, then I probably would go ahead and distribute, so I didn't have a fraction until the very end of the problem. Okay, on this problem, you're going to distribute and then simplify. So start by distributing the 3 here. You're going to have to be careful because you're distributing a negative 2. So we have 6z plus 75 minus 2z plus 2 equals 78. Next thing you want to do is combine like terms. So I have a 6z and a minus 2z. Now be careful, I'm going to show you something, then I'm going to erase it, so don't write this down. But what some people do is they see this minus 2z and they say, oh, I'm going to add a 2z to both sides. There's a problem here. Okay, and if you think about it, remember that one of the rules for solving equations is whatever you do to one side, you must do to the other. The problem with what I just did was this is on the same side of the equal sign as this is. So what I really did was added 2z twice to the left side of the equal sign. So that you can't do. So we need to combine like terms that are on the same side. 6z minus 2z is 4z. 75 plus 2 is 77. Now I'm ready to start doing things to both sides. Subtract 77 on each side. We get 4z equals 1. And divide each side by 4. We get z equals 1/4.